The unit circle can be pretty daunting if you look at it like this. What are all these numbers? How am I supposed to remember all this? I, for one, needed some kind of memory tool to help me cope with all of these numbers. For me, this was the hand trick. But first, what info does this hand trick even give me? What does it represent? The hand trick gives you the coordinate values for special angles on the unit circle. The special angles in the first quadrant include 0, 30, 45, 60, and 90 degrees. Here are the rest of the special angles. What the coordinates given by the hand trick really represent are the base and the height of a triangle that is drawn outward from the special angle from the center of the unit circle. These coordinates are very useful in any problem involving triangles, which show up all over in architecture, geography, astronomy, and even digital imaging. But before we move on to the hand trick, make sure you know the signs of each quadrant. The signs of these coordinates will come in handy later when we deal with angles other than 0, 30, 45, 60, and 90. As I introduce the hand trick method, let's start with a relatively simple angle, like 30 degrees. In order to solve any angle, we are first going to need this nifty little formula, the square root of the number of fingers divided by 2. The number of fingers represents how many fingers are on either side of your hand, separated by the reference angle, in this case 30 degrees. So on the left of the reference angle we have 3 fingers. We plug this into our nifty little formula, and that is the cosine of 30 degrees, also our left coordinate. We can do the same for the right coordinate. There's 1 finger to the right of the reference angle, so the right coordinate is root 1 over 2. This right coordinate value represents the sine of the reference angle, in this case 30 degrees. However, we still need to reduce this to make it look exactly like it does on a unit circle. There's not much to do here other than reduce the square root of 1 to 1. Let's do a recap. First, we learned what the coordinates really represent. Second, we learned how to determine the signs of each coordinate. And third, we learned how to determine the values using the hand trick method. Now let's get a little more practice in before we move on to more complex types of angles using this hand trick. Let's start with a 90-degree angle. For the left coordinate, we will need to count the number of fingers to the left of the 90-degree reference angle. However, there are 0 fingers there. So our left unit circle coordinate for 90 degrees, or the cosine of 90 degrees, is simply 0. Awesome, now let's find the right coordinate, which is also the sine of 90 degrees. There are 4 fingers to the right of the 90-degree reference angle, so the right coordinate is equal to root 4 over 2, or which is also the same as 2 over 2, which is also equal to 1. Therefore, the right coordinate, or the sine of 90 degrees, is equal to 1. So, the unit circle coordinates for a 90-degree angle are 0, 1. Let's try another example a little bit faster. Let's find the unit circle coordinate for 60 degrees. There is 1 finger to the left of our reference angle of 60 degrees, so the cosine of 60 degrees, or the left coordinate, is root 1 over 2. However, this can be reduced further to be 1/2. So the cosine of 60 degrees, or our left coordinate, is 1/2. Now let's find the right coordinate, or in other words, the sine of 60 degrees. There are 3 fingers to the right-hand side of the reference angle. So the sine of 60 degrees, or our right-hand coordinate, is root 3 over 2. So the coordinates for a 60-degree angle are 1/2 and root 3 over 2. Let's try this with an angle larger than 90 degrees. What? How am I supposed to do that on one hand? To find the coordinate of an angle larger than 90 degrees, you need 2 pieces of information. 1, the angle from its closest axis, and 2, the quadrant it's in. Let's find the coordinates for the angle 210 degrees. 1. Find the angle from 210's closest axis. The closest axis to 210 degrees is the x-axis at 180 degrees. The difference between these two angles is 30 degrees. 2. Now find the quadrant 210 degrees resides in. Great! 210 degrees lies in quadrant 3. This means that the signs of its unit circle coordinates are going to be negative, negative. Now we have all the information we need to find the coordinates of an angle greater than 90 degrees, in this case, 210 degrees. Now let's try using the hand trick, using the reference angle of 30 degrees and the signs of the third quadrant, negative, negative. There are 3 fingers left of the reference angle, so the left coordinate, or the cosine of 30 degrees, is root 3 over 2. However, we attach the negative sign because 210 degrees is in the third quadrant. There is 1 finger to the right of the reference angle, so the right coordinate, or the sine of 30 degrees, is 1/2. However, we still attach a negative sign again because 210 degrees is in the third quadrant. So the unit circle coordinates for a 210 degree angle are negative root 3 over 2 and negative 1/2. Now I have a challenge for you. Find the coordinates of a negative angle. Let's try negative 60 degrees. Hint: you first want to find the angle to the nearest axis, and then secondly, find the signs of the quadrant it is in. Now pause the video if you want to solve it yourself. The answer will be on the following page. Thanks for watching!